Okay, we are live. Welcome everyone to the new episode of Tech Excellence Meetup. My name is Daniel Moka. I will be the co-host of the today's session. I'm super excited for this day because of two reasons. One is that I'm going to introduce you another co-host who will help me and Valentina to host sessions in the future with the Tech Excellence. Our community has grown a lot and we needed to extend our core team. We have great plans for the futures, great sessions, so stay tuned. And the second reason, I'm super excited today because we will have a really exciting session with an important topic and with an amazing speaker. So let me introduce to you our new co-host, Oliver Ziller. He's a full stack software engineer from Switzerland. He works at Swisscom. He's a big fan of extreme programming, being a software craftsman, and also he's a fan of agile practices. So, Oliver, I would like to ask you to continue from here, and yeah, the microphone is yours.
Thank you, Daniel, for this nice introduction. I want to also thank Valentina to giving me this great opportunity to be here as a host or a co-host, and because I just can talk to so many great people. So, but for anybody who doesn't know us yet, who are we actually? Well, we are Tech Excellence, as you can see, and our vision is to raise the bar of technical excellence across the world. And how do we do that? For example, with these sessions that we have here. So we already had some great sessions in the past, and we will continue to have great sessions in the future too. And you can follow us here on all the social media like Meetup or YouTube or LinkedIn, of course. But now to the meat of today. It's our speaker, Peter Gfader. Peter is a software architect, a consultant, and a trainer at Beyond Agility. As far as I know, that's your personal company, your own company, right? He calls himself a silo thinking breaker. I think that's pretty cool. And according to your bio, you love coffee, which I can say I do that too. So today you will be explaining us the key concept in computer science and how it relates to acceptance test driven development. So we are really excited to learn about that. But before I hand over the mic to Peter, I just want to remind the audience that if you have any comments or any questions, just put them down in the comment section so that we can then pick them up after Peter's session and discuss them together. But now I have talked enough and I give over to Peter. Thanks.
Thank you, Oli. Thank you, Daniel. Thank you, Valentina, for organizing this. It's amazing that you have built up this community and you have so much drive and energy that you put into this. Great, great. Thank you very much. Now, I want to talk about the most important concept in computer science. Now, who am I? I'm just a random guy, and now I'm telling you what the most important concept in computer science is. Actually, this doesn't come from me. So what I want to tell you is I collected a lot of things during the last 20, 30 years, and I have put them all together in a nice chain that we look at today. There are different tools, there are different workshops, there are different practices that I'm combining. And what I really want to take away for you is do try this at home. So what do I mean by that? All the things that we are discussing and we are discovering today, I would like that you have them as workshop in your organization, in your team, and things like that. So I'm going a bit fast to go through all the content, but I'm looking forward to the Q&A section where we dive into specific topics which we don't have time to cover during the first 45 minutes. All right, when I discover this concept? Now, the first time I discovered this concept was back in Australia. I was living and working in Sydney, Australia for a couple of years. It was 2008 until 2012, roughly. And I was working with an offshore office in Beijing, in China. We had around 40 engineers there, and I was the tech lead for a product that we have built for an Australian client in Sydney. And I had workshops with the developers in Beijing, and we had a lot of communication, Skype. At that time, it was still called Skype and things like that. But the interesting part was always to communication, obviously. Me not being a native English speaker, the Chinese people not being native English speakers. So there was a little bit of friction, obviously. Communication is hard. We know all that. This is one important aspect of technical excellence, for sure. But the other interesting piece I discovered then is when someone told me, hey, Peter, where should we start coding? Like, where is the first line of code we should enter? And there are different ways on how to find it out. I give you one way that you should not do it. One way you should not do to find out where you should start coding is use the debugger. Basically, firing up the application, adding breakpoints in your application, finding the place where you add the little if statement, and then move on to the next task. Don't do this. This is not how we want to write code as engineers and to try to come up with solutions for our customers. So the question was always, where should we start coding? And what I discovered there is it relates to where do we do the first step, but also where do you start with test-driven development? It's kind of related. Now, what is this concept? Now, this concept comes from John Ousterhout, which has published a very interesting Google Tech Talk, where he just talks about his new book that he wrote. It's an amazing, great book that I can highly recommend. And this talk as well. And in minute 3, John asks the students this question: what is the one concept that is most important thing in all of computer science? And his answer is problem decomposition. And that's what I think is the biggest problem that we try to solve. Now, Hendrik Knieberg, a Agile coach, consultant, craftsman, a great guy, check out all his material as well, has a different way on how to put it. He basically called it splitting the system into useful pieces. And this is the concept that I want to talk about today. Like, how do we decompose a huge product vision into smaller goals, into smaller steps, into sprint goals, if you're a Scrum guy, into daily outcomes, into tasks, into minutes where you actually write a commit statement, you push it to production, and you go home happy on a Friday afternoon. So this is the major concept I want to talk to you about. Splitting a system into useful pieces, or in other words, problem decomposition. Before we go there, I want to talk about another topic. And the first topic I want to talk about is, I think we are always in a product-driven context. We might be constrained by a project, but we are always a software engineers in a product-driven context. Software is always a product. Now, what do I mean by that? Now, if I say project, I typically mean this is a reference from the Project Management Institute. Similar definitions you can find on the Prince2 website or Hermes or project management guilds that you find on the internet. A project is really something unique with a constrained time and constrained resources. But if we talk about a product, that's a completely different thing. Like if we talk about products, we talk about how likely am I going to tell all my friends about the little app that I'm using? So sometimes we explain this also by showing hearts, like, do people love our product? What's the experience? What problem do we solve? Do we actually solve a problem with that product? We talk about the long-term view of things. We talk about value. We talk about return on investment. So this is a different view of than a project mindset. The reason why I'm talking to you about that is because software is always in the product constraint. So if you want to talk more about project versus product, we can do that in the Q&A section. But for now, we stick with this definition. A product is long-term. It's about solving a problem for our users, having a great ROI and things like that. So it's a very different thing than a project. Now, with that definition, I would like you to focus on this model. Now, here is a model where we talk about good products. Now, a good products, so the first bubble that you see here is we are trying to build the right it. What does that mean? We are trying to solve a problem. We are trying to build something that lets people do something better, solve a problem, have a happy life, things like that. So this is the first bubble that I'm talking about here. The second bubble here is, are we building it right? Now, this is obviously tech excellence. Here is tech excellence. Excellence means we are building it in a way that we can create the next version. We can sustain it over a long time, not just one sprint, not just one day, not just at the end of the project. It's actually a long-term investment. And the last one actually here is, sometimes I call it time to market, but it should be called the right time, because you can also be too early for certain markets with a product. But in this session, I would actually like to ignore the time to market aspect and just focus on the upper two parts. Now, why am I telling you this? The reason why I'm telling you this is multiple facets, actually. The first reason why I'm telling you this is because we, as engineers, we focus on building it right. But as a team, when we collaborate with product owners or product managers, we need to also find out how can we actually build the right product or the right feature. So I think for us as engineers, it's very important that we have a clear understanding of the left-hand part as well. Second, communication, collaboration. Third, if we are fast, then we can also experiment and try out ideas and features in the market. So that's also an interesting way of putting it. And the last thing is where we actually go to talk about ATDD and slicing in a second, where I want to highlight how this is related to this model. Usually I ask the people, do you have questions or things like that? But this is not a workshop, so I need to talk to myself, kind of. It doesn't really matter today. I'm talking to the screen and I'm just seeing myself, which is fine. Now, if I look at this model, now everyone obviously wants to be in the middle here. What you see in the middle here is basically, I want to build the right product on the right amount of time. So there is enough market there. There's enough people wanting my products. There is enough people that spread the word of my product, and building it right as well, where we actually can sustain that product for a long time. Now, I have a longer session where I can tell you also examples of the various areas. Now, one area that is quite interesting, which I'm not going to talk about, is this area here, and this cross-section area here. But for today, for this evening, we are not going to talk about that. We are just using this model as a thinking on how it relates to ATDD and slicing, which I will going to explain in a second. Now, many of us have said about this, you can't be agile if your code sucks. So what do I mean by that? There's a talk that you can find on YouTube. If you Google with your favorite search engine for "you can't be agile with your code sucks," then you find that talk. And the basic notion is really agility has nothing to do with building it right. Agility has to do with, we want to provide value to the outside world, outside of our organization. So just building it right with the right quality is not enough. It's actually more. We need to build the right product. We need to solve a problem in the world, and it needs to be used in the world. Otherwise, it's not a good product. And then we are not really focusing on agility for our organization. Now, there are other models that go in a similar way. I will show it to you quickly. Maybe there is a question later on where we want to compare these models or things like that. So the first model is from Alan Brown. So he thinks about what is desirable to users, what is feasible, viability in the market, and cultural change necessary. So the cultural change necessary is quite interesting because it resonates with the cultural change in an organization. Desirability basically means, do people want this thing? Is there a need for that? Do we need to discover the need? Feasibility means, can we build it? And viability basically means, is there enough market in there? There's another way to think about that, which is value risk, usability risk, feasibility risk, business viability risk. And I really like this definition from Marty Kagan, the 4 big risks, because this is really where agility comes in, and especially we as tech engineers can help the business to validate risks. And I think this is a great way to talk to managers. Talk to managers in risk. So don't talk to them about time to market and things like that, but talk to them about how can we reduce risk. Let's talk about how to reduce risk. So first of all, where I would start and always start investing more time and energy is the write it. So start always on the left-hand side. So basically, let's try to find out if there is actually a need, a problem, a service, some people actually interested in that thing. And if we have discovered that, then we can try to think about, okay, now we build it properly with the right test approach and harnesses and monitoring and infrastructure and your Kubernetes love and all these things. But first, I would always recommend to build the right it. There's a great way on how to do that, which we are not diving too much into the details tonight, but it comes from Alberto Savoia. He's the author of the PretoTyping book. And he basically says, start with the XYZ hypothesis. So here you have the hypothesis, and it says at least X% of Y will do Z. So for example, at least 5% of widget buyers will buy my new widget for $20. Now, if you have made up this hypothesis of a product or a feature, you can hyper zoom. With hyper zoom, he basically means make it smaller. Not widget buyers in Switzerland. Widget buyers that are online on Friday afternoon. Make the target audience smaller, make the experiment smaller, and try to learn. If you have validated that assumption, go the next step. And this is called PretoTyping. It's not prototyping, it's PretoTyping, because with the next step, you're pretending that the feature is there and you're gathering data. So you're gathering data. Is this actually worth building? Yes or no? And this is very, very important because we are building too much software that no user ever uses. So with this technique, I think we can solve a lot of these things. So once we have discovered that we should build the right it, I want to answer the question, so where do we start with ATDD? Now, what I discovered is that a great team dances around these fields. What do I mean by that? By that, I mean that great teams, and by great teams, I include every engineer and every product manager and every product owner. They start potentially here, they move over there, they're doing something on the market, then they have another feature, then they see, okay, let's invest more in quality, let's figure out if we're on the right time, let's invest more in the quality, let's build a new feature, and they're dancing around this visual here all the time, which is amazing because then we have all the same understanding. What are we trying to achieve? Are we solving a problem here? Which product actually gets a greater market, or is there a new market that we can discover with this product? So with ATDD, my recommendation is, if you look at this model, start on day one. And the reason why I recommend to start on day one is the clarification mechanism. What does that mean? It basically solves the question, do we all understand the same thing when we talk about that feature? And this is already huge if you can do that. Because I see way too many teams that collaborate, and then they run in one direction, but they're not clear, are we all talking about the same thing? Or people are building the same stuff, or people are doing this and the other team is building the other things and they are not working then together, things like that. So with this notion of writing acceptance criteria and an acceptance test before you do anything else, you make this very, very clear. And the interesting thing is, you could also write your XYZ hypothesis as an acceptance test. Now think about that. Now the second part is about documentation, because later on you could look up in your wiki or your favorite documentation tool, what did we try to achieve in the last sprints, weeks, or whatnot, and you have it as a memory there. And maybe you add automation once you're getting a clearer picture. All right, so this is where should we start with ATDD, and we're looking at this model. Now, I need to define some more terms. Today, I'm using a very, very simple explanation of complicated and complex. And the explanation is the following. So if you want to dive into all these details, what this is about, look up the Cynefin framework after this talk. Don't start Googling yet, and stay with me for a second. So what I'm trying to explain next is the difference between complicated versus complex. Now, in a complicated domain, you can clearly see if I'm doing this, this is going to be the outcome. So there's causality. In a complicated domain, there we have machines, we have rules. If this happens, that other thing will happen. If we are writing this piece of software in this manner, we will see a certain outcome later over there. This is complicated stuff. And I would say writing software, just the act of writing software is complicated. Now, I would love to dive into this later on in the Q&A section. If you want to talk about this statement about complicated versus complex, Peter, we need to talk about that. We can. Now, what is complex? Complex is when you get surprises, when you have humans in the loop, when principles work better than rules. So principles over rules in a complex domain. I'll give you an example to think about this. First example is if you have a blue screen of death with your Windows machine. Is this a complicated problem or complex problem? Now, it's a complicated problem because with enough time, money, and expertise, you can find out why this blue screen of death happened. Now, if you want to go to Berlin, Freiheitsstraße number 1, from here, from Zurich, and you want to know the shortest path, that's also a complicated problem because you can find the shortest path on a map with your favorite tool. But if I want to know what's the fastest path to Berlin, Freiheitsstraße number 1, you can't answer the question because you need to start driving. And once you started driving, you get tired, or there's an accident, or there's a traffic something, or there's snow on the street, or your car has a problem. So this is a complex problem, and the other one is a complicated problem. Now, why am I telling you this? I'm telling you all this because there is one important aspect which is related to planning and slicing, where we're coming to in a second. So here is the first model. We are going to, sorry, this is not the first model, but one of many models in this talk. And this is actually a German one, as I see. So plan, security is the wrong word. Safety is also not the right word. Now, how sure are we that the plan works out? And here on the x-axis, we have time. Now, initially, when we start planning, we get a lot of safety and we discover a lot of things. But after a while, more planning does not really help. We could still draw another diagram, another architectural model, another tool. We could have another workshop or things like that. But there is not a lot of value here later. Now, there is some point here, and this one is very, very interesting, that you need to find out where is that time where we actually start coding and stop planning. In other words, when do you stop planning and where do you stop doing? You get into the code base, you get into the product development, you start doing, instead of thinking, analyzing, planning, and things like that. And I can't tell you where this X is because it depends from your organization, it depends from your teams, things like that. The only thing, or the only heuristic I can give you in my experience is I would do it earlier where it still feels uncomfortable. Early and uncomfortable. Start then. And then you will realize, why is the team not happy yet? Why do we need to have more details? Why do they need to talk more about things? And then that's something interesting to discover. Do they need more details? Are they not enabled enough? Do they know how to learn the domain, the technology, and things about that? So in the end, it's really about learning. Another way on how to look at this, the value of planning, comes from Scott Ambler. And he has a slight different model. This model looks like that on the x-axis he has effort, and on the y-axis he has value. And the more effort you put into planning, the more value you get, obviously, out of it. Now, if you talk to traditional project managers, and I'm saying here project managers, because with project managers, there's also this mindset that if you plan enough, you will find the best plan. But in a complex world, there is no best plan. There is no best plan. There is no gun that does not exist. So in traditional theory, that, yeah, you get my point, I think. And so what Scott Ambler basically says, here is the point where you should actually start doing. And he has a couple of numbers here as well. Basically, he says in initial enterprise modeling, 1 or 2 weeks, initial visioning, several days, sprint iteration up to a few hours, just-in-time model storming, maybe 5 to 15 minutes or max 30 minutes. And this reminds us of event storming and other techniques that you might be familiar with already, that help you to get your mindset in the thinking of how can we plan less and start doing earlier. Especially, and I found this very interesting, while doing, you will get a lot of knowledge and you learn a lot, which is exciting. Here is another chart. This is actually an enriched chart that I did myself. Here I talked to other Zürcher engineers. They were actually working in hardware and software. So hardware, software, firmware, embedded software, things like that. And they said in complex system development, it's more than 1 to 3 months if where you stop analyzing and try to start implementing. There is one interesting point I want to mention here. If you don't stop early here in that model, let's make it green, then you build up waste, because here you spend more time in planning, analyzing, modeling, and things like that, and potentially you create a lot of waste. And this is a quite a fascinating symptom that I got infected with as well. Like if you're creating a diagram or a UML model or something, and you get to attach to it, it's like your baby. You spend so much time with your baby, you get attached to it, and then if someone wants to change it, you are not so happy anymore. So this is also quite interesting. Let me just see where we are. It's 6. Okay, cool. Now, so this is one topic that I wanted to cover, is about when should we stop planning and start doing. So this is something maybe you find helpful. We can also talk about that in the Q&A session later. Now, another couple of terms that I want to introduce you. And the first term is breakdown or task breakdown. What we mean by task breakdown is the following. By task breakdown, I am creating work in layers, basically. So update database with customer something, query, blah, 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 technical stuff. Very exciting, very exciting. This is all necessary to do, but we are breaking work down into tasks. Tasks are for developers, for engineers. We want to know what we're doing. This is breakdown into tasks. Now, what is slicing? Now, with slicing, what we mean, it's vertical, testable, user valuable, and it cuts through multiple architecture layers. It could go to production. So slicing is this notion of breaking things into smaller pieces so they are still valuable. And you might realize, wow, that's hard. And this is actually very hard. And I will show you a couple of things on to take away and try to practice that. These pictures come from Alistair's and Henrik Knieberg's workshop. I will have a link on the workshop as well later on. If we want to talk about that workshop, we can in the Q&A section. Let's do it this way. Let's have a look on the next topic, which is still slicing, because I want to mention something. So if you're doing task breakdown, typically it looks like that. create the database first, then the data access layer in a second, then a queuing system or whatever, and then finally the presentation layer. And then if you spend months down here, that's obviously sad, because up here it gets very, very interesting, because here are our users. And this is very important because we want to solve a problem for their world. So with layering or component teams, you're basically delaying feedback, you're delaying the time to connect to these people. And what we are trying to propose basically is slicing small chunks out of your product vision. And it looks like on this picture, and I have to smile a little bit on the inside, because in PowerPoint or in a Miro board or on a YouTube channel, it looks very simple. And it's very hard though. And that's why we're here. So sprint 1 could be a little bit UI and nothing else. Sprint 2 could be little UI, and maybe we have discovered a way to store data. It's not our database yet, but slowly it grows our system and things like that. The hard part here is our database is growing over time. So initially it starts with a customer table with 2 fields, and slowly it gets bigger and bigger. And then we need to think about, but hey, we have production data. We have millions of records in that production data. An alter table or an alter index will cause some friction. So this is very, very hard, but still, again, worth doing, because we want to work in this incremental, iterative way, which is great. With tasking, you are limiting the option. That's one interesting observation I made in the past, and I got this from a trainer friend. He tries to delay this as much as possible. Well, as soon as you talk about tasks, you're set, because you talk about databases, you talk about technology, and everyone in the room will have the thinking in that direction. So we try to postpone and delay that as much as possible. Now, I talked already a little bit about acceptance testing without defining what acceptance testing really is. Now, today I won't have time to do that. I just give you a couple of hints. Actually, it says up here, skip this, but I need to cover some basics before we can go further. Now, there's a talk where I dive into details about this. Acceptance testing sounds easy, but it's hard to get right. Please watch that later, this meetup. And there we define acceptance test asserts that the system does what the user wants. So we define 3 types of testing: development, acceptance, and exploratory, with acceptance most valuable. Here is my opinion that is different than Dave Farley's opinion. So acceptance testing has a different view on acceptance testing than myself, which is cool, because then we can discuss and talk about that if you want to dive into that later in the Q&A section. Now, one concept about ATDD is really the examples, which I found very, very helpful, because it's again about communication. And the last piece I wanted to mention is, this is all coming from the other recording we did some months ago. What does acceptance testing make possible? Now, there are at least five benefits of acceptance testing. Please check it out in the other video. But here, I just want to mention a couple of things that I found interesting. Is you change the communication between people if you practice this. So typically, you get people approaching you and telling you things like, given I'm in this situation, when I do this, then these things are happening. Ah, okay. But is that right? Does our system behave in that way? Oh, let's try. Let's write a test. Let's write and see what happens in that scenario. And this is a very powerful technique that I'm very big fan of. Communication, same picture, same understanding, things like that. Now, with slicing, why do we slice our product into smaller pieces? There's one important thing that Scrum and Kanban have in common. Now, I'm jumping here from topic to topic, and slowly all these little knots that I'm collecting here, I hope they make sense in your head. So the good things in product development is high bandwidth, fast feedback. So we want to do something and we want to learn, hey, did we build it right? Did we build the right it? Can we build it? Is it a great product? Do people like it? What's the feedback? Does our servers can handle the traffic? And this is all feedback loops from your little IDE where you type in some code and the IDE tells you, hey, you had a compiler error, back to production where you get feedback from production users of your thing. So high bandwidth, fast feedback is important, and we can achieve that. And this is interesting, and this is why it relates to slicing with small batch size. Small batch size basically means we want to deploy little chunks of work into production to learn and things like that. Now, I don't want to talk about Kanban and Scrum, but both things, let's call them tools for now, try to reduce the batch size, which I found interesting. There's also a hidden frame where I can talk more about Scrum and Kanban if that really interests you in the Q&A section afterwards. Now, is this a good example for slicing? I'm waiting for some feedback, but since I'm alone here, I won't get any. Doesn't matter. I continue. So what we see in this picture here, someone has cut the tennis balls in pieces, and it's interesting because, yes, this is a good example. And the good example is in the, let's make up something, recycling of tennis balls, storage, decrease. Domain. Sorry, I'm just putting things in a collection of words. But if we are in the domain of recycling tennis balls and we want to store them in a shorter amount of time, this is a good example. It might not be a good example if we are we want to store as many balls as possible. So what do I try to explain you with this exercise? With this exercise, I try to explain you without a goal, slicing doesn't make sense. So you need to have a goal. You need to have a vision of your product. Otherwise, slicing doesn't make sense. Right. Did I say anything? What is the business domain? Yeah, that's the key important aspect. Okay, let's dive into slicing. Thank you very much, Neal Killick, for the following workshop that he pushed online, because the next couple of things come from his workshop that I will have a link in the references in a second. Now, Neal asked the question, how do you slice an apple? Now, this is easy because you cut out a piece of apple and it's still valuable. You still get the juicy, fruity, nicely smell and everything if you want to eat an apple. If you want to store apples, slicing apples is a different story. But depending on what you try to achieve with the goal, slicing an apple is an interesting question. Now, how do you slice a Rubik's Cube? Again, what are we trying to achieve? Let's say we want to have fun playing the Rubik's Cube. Now, how would you slice that? This is hard because you can't just cut out a piece. If you cut out a piece of the Rubik's Cube, you cannot play anymore. So slicing a Rubik's Cube is a very, very different problem than slicing an apple. And here are the 3 things that come from Neal Killick. He has 3 levels of story slicing. The first one is capability, functional, and then the technical one. Now, let's dive into these 3. Let me just add a note. There is the Affinity Carpaccio slicing workshop, which I have a link to in my references. We are not going to talk about that tonight in much details because I think it's very documented on the internet from Henrik and Alistair, so you can find all the details on how that works and do it and run it yourself. This one is not documented so well, so I have done a couple of things for you that you might be able to run it at your company, or maybe not. All right, so capability, functional, technical. Let's dive into the capability slicing. Capability slicing is where you try to identify themes in your story. So here is an example. Enable Acme Bank customers to bank with us online. Now, what might be the themes for this user story? Now, I need to explain what a theme is. A theme Now, a theme is a place where you can alter the behavior in your program without editing in that place. This is not the theme that Neal means here. This is the theme that comes from Michael Feathers, which in this community, I think everyone is clear what that means. This is about interesting approaches on how to change the behavior of your system for testing purposes mainly. But in this case, when we talk about themes, we want to find enabling points where we can slice this story into smaller pieces. And the enabling points are the following. Maybe someone can guess that already in the chat, but since I know that the chat is delayed by a couple of minutes, seconds, I need to just show it to you. So the first theme is Acme Bank customers. Now, who are they? They might be private customers with a lot of money, or they might be corporations. So these are different customers. Second theme is bank. To bank. What does to bank mean? Do you want to pay a bill? Do you want to invest some money? Do you want to, whatever banking service we're talking about? And the third theme is online. What does online mean? Is it on your little screen doing something with an app or a mobile device? Or is it on a desktop with hundreds of screens as I have here? Or what does online really mean? And along these three themes, as Neal mentions, you can break down the problem into smaller pieces. Let's have a look on the example that Neal shows. So we can actually break it down into 5 customers. Small business, large business, new customers, mortgage customers, school kids. 5 slices. Now let's go to bank with us. Pay their bills with BPay. BPay is similar to PayPal. Customers can transfer money, request an overdraft, apply for a new account, apply for credit. We have 5 slices. 5 times 5 is 25 slices. Let's move on. Online, mobile phone, desktop, laptop, iPad, Android. Another 5 slices. Now, if we combine all these 5 slices, we have 125 stories. Wow, I can see already Jira blowing up. There's way too much Jira stuff in here. Now we need to manage 125 stories. Now, I don't want to talk about Jira or Jira especially here, but maybe you need to rethink on how you use your tool as a general thought. And not everything that you can come up with needs to be managed in some way. And now it's interesting because you, as engineer plus product managers plus product people, you can now prioritize these different slices and say, hey, small business customers, we need to really do something for them. They are very, very important. Let's focus about BPay and on their mobile phone. If we can release that for the next conference or for the next Christmas period, or I don't know, we would have a major benefit. And the second interesting thing here, this is actually the note that I added here, is once you get these slices more concrete, they get much more creative. Because as a customer, I want to bank online with us, boring. But if I say, as a family father with 2 babies, I want to get a loan to build or to buy online via the iPad, that's exciting. Family father, okay, what does that mean? And things like that. That's now getting very, very interesting. So more concrete is also more creative. Second level, functional slicing. The functional slicing, what you're trying to do is basically user story mapping from Jeff Patton. If you have not come across Jeff Patton or user story mapping, you highly need to check his work out. He's written a lot of good books, and from him comes also this technique called user story mapping, basically where you try to map a customer journey through your system, and you try then to find out what are the most basic options on how to achieve that, and what are options that might be interesting in the future. I don't have an example here, but let's give it just an example. For example, in the step 2, the customer needs to select something, a biller. Now, in the most basic version, he could just use a drop-down from available billers that he has already in the system, which are 5, for example. Now, a drop-down selecting things is, from a customer experience, Now, there would be another option on how to achieve this. Select the biller, maybe by autocomplete on the text box or other things. Now, or the system tells you already, hey, there's a bill waiting for you, and things like that. So this is functional slicing. You try to come up with one way on how to get to your system to achieve your goal. The goal is something that you discovered in the capability slicing. And then you try to find options. And the options are very interesting because here, and I typically talk about golden or wood version. What's the wooden version on how to achieve this? And what's the golden version? Golden version would be, if God would solve this problem, what would God do? And what I mean by that is, get again the creativity juices running in your brain, because that's very exciting when you collaborate as a team. All right, let's go into the third level. The third level is technical slicing. Now, it's based on this concept called the hamburger method. And basically what you try to do is, once you discover this user story map where you run through the system, you go down on the level of the technical tasks. And let's have a quick look on how that looks like. For example, here, in order to enable banker customers to pay their bills with BPay on your website, we need to select an account, select biller and things like that. And then you try to discover, okay, how do we get the user the selecting of accounts? Okay, we could run a SQL query to the database, or we could have an optimized store proc. Now, this level is really tasking, because now we're talking about implementation details. This has not really something to do with slicing anymore, I would argue. And I did not have this conversation yet with Neal, but it would be interesting. For me, this is more about tasking. But again, here you try to find different options on how to solve get billers, for example. And then you have the conversation in the team, where should we invest time? Should we hardcode billers, or should we fetch the billers from a database with highly sophisticated automated routine, predictive analysis, blah, blah, blah. And somewhere you need to have the conversation, this is how we do it, which is great in the team. Cool. So these are the 3 levels of slicing that came out from this workshop from Neal. Now let's connect that to ATDD. The connection to ATDD is fairly simple. Every slice should be driven by an acceptance test. So once you are on the level of functional slicing, you have an outcome that you want to achieve, and you could write an acceptance test for that. So for an example, enable Acme customers to pay their bills with BPay on your website. You could write an acceptance test on that level, or you can go down a level here. Giving customer Paul Powell, well-known proto persona in your organization. This is important. Everyone needs to know who Paul Powell is, because then we know, okay, he has an account with specific settings, with a specific money and things like that. If he's logged in, navigates to payments, bank account has $1,000 balance, when bill is valid, the amount is 500, with other details are submitted, then the bill is paid. This is an acceptance test for that scenario, and we could break that down into smaller acceptance tests and things like that. And this is how we relate functional slicing with acceptance test-driven development, which is, in the end, fairly obvious, I would say. Cool. Let me have a quick look where we are. We are doing great on time, because I have 11 minutes, and I want to tell you a little bit why we do this slicing. What for do we slice our products? There are multiple reasons. We want to learn faster. We want to reduce our batch size. Kanban, Scrum, interesting. We want to happier stakeholders, because we want to find out, is this what you wanted? Is this what you wanted? Is this what you wanted? Can you use this? How would you use this? Try to solve this problem with this product. Is it fast enough? Is it good looking enough? And things like that. Is it sexy enough for you? So everyone tells you that you will tell all your friends about it. More sync with other teams. This is interesting when we talk about Conway's law, where we have a lot of different teams in your organization that are working on the same product. Better prioritization, because you can prioritize now on little things and not bigger things. Less risk, because we try to minimize risk by working software. Agile Manifesto, working software is our main goal. We get a sense of speed, which is a huge motivational factor in my experience, because suddenly people are, wow, we make happy customers. That's exciting. And planning gets easier. And if you deliver more slices, if you're releasing more often, typically you can have more apéros, you can celebrate more usage, feature usage, and things like that. So what I'm trying to say is, don't celebrate, we released something to production or you deployed something to production, but celebrate that your customer is very, very happy with your product, which is a very, very different thing. Now, I mentioned here 2 new terms, and the 2 new terms I mentioned were deployed versus released. Now, there is, again, a lot of YouTube videos where I explain this concept. Here is another one. And with deployed, means we have a change in our configuration, our code base, our infrastructure, or whatever it is in our system that is introduced in the production environment. This is deployed. Not testing UAT or another environment, but to production. And released means we are the users are able to use it. They are able to see and use it. And if you can distinguish these 2 things, you have a high technical excellence in order to close this loop about technical excellence, why we're all here. Now, how we are going to do that? There are at least 3 options. I will explain them to you if you watch that video that I have also in the references. How do you distinguish deployed versus released? Cool. I come to a slow conclusion area. I don't have a real conclusion of the whole thing. I'm just trying to put some thoughts in your head, and I'm trying to somehow connect different topics together. And I hope you find that beneficial. So I'm looking forward to the Q&A section. One topic I found very fascinating is the Conway's law, and there is an extension and also recording of this extension that I proposed. And basically, what if people that slice the product and people that build the product are not the same? What do you think will happen? So people that slice the product are not the same people as that build the product. You will get some interesting behavior of engineers. And one behavior might be explainable also with the Conway's Law Extended, which is a YouTube recording that you might watch later. All right, how can you practice slicing? Let me fix that little typo here. I don't want to talk about concepts anymore, because the most important concept in computer science is problem decomposition, breaking things into smaller pieces, slicing along value. Slicing along value means it's still valuable for our users. Now, how can you practice this slicing technique? There are 4 workshops, and basically these are the 4 workshops that you find in the references. The first one is Beyond Invest, that comes from Neal. It's not really a workshop, but it's fairly simple to create a workshop out of this. If you're struggling with that, just send me an email, then I will help you. The second one is Elefant Carpaccio's workshop. The third one is Sabamedo exercise. And the fourth one is from the Salmon Coaching Society, which I'm a proud member of, this learning hour about testable design, where you try to come up with functions and slowly build up your system out of those. And here are much more reading material that I will send you in the chat in a second. And with that, I would like to close down. There is my contact information. This is my bio. If you send an email to that email address, you will get all the material that I am showing here tonight. Let me also add that to the comments here. Hey, Peter Koch is here. Cool. Can I not post a comment here? Doesn't seem so. Okay.
Sorry, you can maybe put it in private chat and then we can transfer.
Cool. This is a little link that opens up your favorite email software, and then it will shoot me an email, and there is some automation robot that will answer that email for you. And the last thing I wanted to mention, I'm giving trainings in this topic. One of the trainings is called the Agile Scrum for Software Development. There is a discount code called MeetupGFP2. If you use that, you get an amazing discount. Please sign up, and then we have some fun together learning on how to be better engineers. And with that, I'm looking forward to all the questions that you have. I can't answer all the questions because you might have some private questions in your life which are out of boundaries, but let's see. Let's have a discussion.
Well,
Thank you.
First of all, thank you, Peter. It was very interesting. My brain is now again full of anything that I haven't known before.
Cool.
So it's amazing. How do you do that? How do you fit all that in your head? It's just amazing.
I don't.
You don't.
I have a huge notebook where I collect things, and then
Mhm.
every now and then I try to bring these things together. ATDD and slicing and project, and somehow planning. When do we stop planning? When do we start coding? Then sometimes it makes click in my head, at least. I hope it also made click for some of the viewers.
That was actually very interesting. Also, this when do you actually start to program and stop planning? Because if I hear that as a developer, I would say I stop planning. I don't like planning. I just start. But probably that's not what you meant by that.
We could start a new hashtag called noPlanning.
Mm-hmm.
But that's not what I'm proposing, no.
Okay, great.
I just want to say something. I think the hashtag would be even more popular than the no estimates tag. Because if the no planning tag got adopted, then estimates could also fall out of the picture.
Totally.
Yeah, they say, planning is useful, plans are useless, right? So, but yeah,
And
some planning is needed, as Peter said. Some we need to do that.
Totally. Maybe before we dive into the Q&A section, maybe let me add one point what I found interesting about planning. If you have a strong product vision, a lot of planning will go away. What do I mean by that? If we look at, typically I make the example from SpaceX. SpaceX has the mission, the vision to colonialize Mars. Now, I don't like that vision at all because I don't want to live on Mars. Totally, no. But it's a very strong vision, and it helps all the organization to align in one direction. What I mean by that is if I go to SpaceX and I run a workshop about ATDD, for example, it will not last long until an engineer will raise his hand and he will ask a question, will say, Peter, how does ATDD lead us faster to Mars? And if it doesn't, we stop. So you can stop a lot of company bullshit, concepts and strategies and plannings and estimating and whatnot we have in organizations. And a strong product vision might help there. Strong product vision, which relates to, again, product over project.
You would imagine that would be the normal case, right? That usually companies have that.
Rarely, very, very, very rarely. At least the organization I work with. And maybe that's why I'm there. Maybe. But a strong vision,
probably.
I mean, a strong product vision is very hard to come up with as well. Like it needs to be far away, not too close. It needs to be motivating. It needs to be tangible somehow, because otherwise people think we'll never get there anyway. So realistic, well, very interesting. What's a strong product vision? But it lets you say no.
Sometimes there are dedicated visionaries, right? In big companies, or I have experience with this. So there are dedicated person who is a visionary, and he's, he or she is coming up with ideas and visions about the product. So sort of visionaries.
But it is quite rare. I mean, I must admit, the most dominant mindset that I see is the project mindset, which happens when project managers from, I guess, waterfall style approach are simply transferred into product owner or product manager roles, and basically they prefer to focus on the outputs that will be produced, and the actual underlying product vision might not be understood by anyone, so they actually might not even be aware of what's the single most important value that is actually being delivered by the product. So I found that to be also quite a common case. I found it quite rare to actually see companies which actually do have a strong product vision.
Totally.
Exactly. Additional, what I also really liked in this session at the beginning, you mentioned that when it comes to successful software engineering, then we need to focus on two things, right? Doing the writing and doing the thing right, and in this particular order. So first of all, we really need to make sure that the product is, we develop the product which is expected by our user. We make them happy with this, and after that, once we know, we verify that this is what we want to build. We build it with best practices. So I really like that point.
Thank you. Cool. Yeah, this is very interesting, because normally, also back with my ex-companies, with the ex-consultancies I work with as a consultant as well, typically if you are the engineer or the expert, you get hired exactly for that part, because you're the expert in doing great engineering. And typically some decisions that are over here will not be shared with you. Just build that customer portal with a mobile support and build it for these customers and let them use a map in Google, whatever. Don't worry about, is it really needed, or is it helpful, or is it actually solving a problem?
And developers don't even meet the users then. It's like, who are they building it for? Where's my purpose? I just do it, but I have no idea if that solves some problem for somebody.
Yeah. In the worst case, they are not allowed to talk to the users.
Yes, that one is definitely common, and where the product owner becomes a wall, and cases where also the product owner is not talking to the users either, and is, for example, inventing both the product vision and the requirements and not basing it on the needs, and then eventually everyone gets a surprise later when the product actually doesn't meet user needs. And what Peter mentioned, and sorry for the interruption before, was how developers might even be prevented from speaking to users. So people might tell them, that's not your job, that's the PO job, or the PO might also feel like, wait, if developers are now talking to the users, what is my role? So it actually, I think, needs a change in mindset to come to the recognition that it's better off for everyone, that they should be aligned regarding business value.
And here is an interesting thing I learned in the past as well. Talking to users is actually very hard, because me as well, I get easily fallen in that trap where I ask them, hey, I built this app. Do you like it? Why should we not ask that question? Because you will gather data about liking an app when you ask that question. But what is more interesting is, are you going to use it? How often are you going to use it? Would you actually pay $100 on the table in a shop for that app? which is very, very different question to ask. And the other thing which comes to the technical excellence point of view is we should ask questions about where the people are expert in. And the people are experts in the problem domain and not in the solution domain. So what is the problem you're trying to solve here? And does my app here help you to solve that problem? And then measure that. Actually, just my doorbell just rang, and I hope my family has a key. Can I go away for 10 seconds? Sorry
Of course,
for...
yeah. Sure. We wait. No worries. Yeah, so far so good. We have a really great topics, really exciting. I think we all learned a lot. We have a comment that is a huge topic and far too short here, right? We could talk about for hours. Hey,
I
Peter.
left the key in the door.
Sure. Absolutely. Have it fixed. Yeah, cool.
Yeah, problem solved.
I want to ask something, but I forgot about. Oh yeah, you always talked about reducing risk. That's the thing you need to talk to business. But I mean, sometimes I have the feeling that some programmers would not like to build it right. I mean, probably those that watch this stream here would, but there are some people that don't want to do, I don't know, refactoring or ATDD or stuff. So when I convince my managers, in the end, they will probably come and say, you now need to do, I don't know, refactoring. You need to have this test coverage up. And probably when you talk about risk reduction, you should always involve your people or your team first before you try to reduce the risk.
Yeah. For me, it depends a lot on which risk we talk about. So typically we have the risk of, are we building the right product? Is there a market? Can people use it? What problem are we trying to solve? So the left-hand side of that model, basically, this part, building right it. So this is a very different risk than we have delivered the first version. Now we want to do the second version. Now we want to go to continuously deploy and release features, things like that. These are very different risks, I think. And what I'm trying to say with risk is really the word risks, because that rings a bell in a lot of managers. So if they don't pay attention, if you talk about technical debt, and there is a whole topic about the technical debt metaphor, which I don't like, which we can go into details if we want to, but I would rather talk about risk, delaying feedback, becoming slower. These are risks which managers typically understand better. And technical debt, and especially investing money, is something like, hey, I want to have a big house. Okay, let's go down that route with shortcuts and technical debt. That's a good thing. So, yeah, I think you have already an upcoming talk about technical debt, or maybe you will have in the future, or you had in the past. But it's a very interesting topic on how you communicate with your organization, technical debt. Now, I'm not sure if I answered that question, but depending on what you mean by risk, I think you would use a different strategy on how to tackle it. And clarity in an organization, do we really mean the same thing? When you talk about risk and I talk about risk, is a general good thing.
So you didn't even once mention something like domain-driven design, but this relates into this topic as well, right?
Totally. How does it relate to this topic?
For example, domain modeling and finding out what we actually want to build. Talking to our people, those that actually want the software.
Yep, totally. It's an implementation detail.
Nice.
These developers will figure it out. No, that's not true at all. Because it has an impact on a lot of things, like how you set up your organization, things like that.
Mm.
But it's related definitely to domain-driven design. I learned a lot of domain-driven design in the last couple of years, and I found it fascinating that everyone talks about the blue book, but no one really has read it. And a lot of people get confused about entities versus values, objects, and they have a long discussion about that. But is that really important? And for me, it made click as well regarding domain-driven design in the last couple of years. What's really interesting? Maybe we can tie that into this talk in a later point.
Mm.
Yeah, I see. I mean, there's a lot of interesting topics and a lot of questions that we also received from the audience.
So
maybe we could start. With some of the questions. I see that question from Maxi is up there first, so maybe starting from there. And there's quite a lot, so we will try to be, I guess, try to go through as many questions as possible.
Okay.
So let's watch the first one from Maxi. Do Pareto rules also apply to validate the hypotheses?
I assume that Maximiliano is referring to the XYZ hypothesis. Let me see. Here it is. And Pareto principle, I think he's referring to with 20% of investment of our time, we want to have 80% of outcome, I assume. And yes. I think from the mindset here, definitely we try to do that. The thinking about this XYZ hypothesis is what is the minimum prototype we could do in order to know we are going in the right direction. Some people call this the minimum effective dose. This comes from Tim Ferriss. He calls it minimum effective dose. Pareto principle is the same thing, yeah. And just to give you a couple of more concrete examples, you could create fake doors, or you could use a landing page, or you could use a mechanical torque, which is basically you're automating a lot of stuff in the background manually. And on the front, it seems like everything is automated. So these are a couple of approaches on how you actually validate X, Y, Z hypothesis in the prototyping example. But yes, in general, the answer is yes to your question. I should have given a short answer.
Great. So the next one, actually, probably a bit longer. Lidoni says, I would like to know more about complicated versus complex.
Thanks, Lidonis. The reason why we need to distinguish these two domains is in the complicated domain, practices are different than in a complex domain. So let's take the planning. Planning makes a lot of sense in the complicated domain. If you spend enough time planning, you find the best solution. Project management mindset. If we spend 2 weeks of planning, we know exactly how to deliver this, whatever it is. In a complicated domain, this totally makes sense. In a complex domain, that's not a good approach. In a complex domain, you need to get faster in this trying or ODA loop, PCDA loop, experimenting loop. Let's use the Scrum language for now. Run a sprint, inspect and adapt. Run a sprint, inspect and adapt. Run a sprint, inspect and adapt. Learning. That works in a complex domain much, much better than in a complicated. That's the reason why we need to distinguish these two domains. Maybe there is a more concrete question you can ask, or if you want to learn more about complicated versus complex, there's definitely the Knevin framework, which has actually 5 different areas, not just 2. I think for software engineering journeys, product development, these 2 are enough to know and understand. But in the Knevin framework, there are actually 5 different domains. I hope this helps.
Yeah, I hope too. So let's move on to the next one. So we have Ando, who is asking, the moment we are stop planning and start doing is related to the MVP instead of a huge product.
Now, there is a short answer. Let me think on from which end I try to tackle that. Now, let's take the long answer. Now, when we say MVP, a lot of people mean a different thing. Let me just go here to this area. And I would rather start asking the question, when you say MVP, what do you mean? Because in the original literature from Eric Ries, Lean Startup, he mentioned the term MVP. And one concept that is really resonating with me with that concept is, what's the minimum product or the minimum that we should do in order to validate a hypothesis? So the focus is again about the hypothesis and not about the product. But since we call this now a minimum viable product, typically most people think, what's the minimum product that we need to deliver? And validating a hypothesis is not the focus anymore. So in order to avoid this confusion, I would rather start talking about what's the minimum viable experiment we could run in order to validate a hypothesis. No, we are building the right thing. No, we are building it right. Can we actually sustain it over a long time? Does our technology work? Can we monitor this thing in production? How is our infrastructure coping with 100 users, with 1 million users? These kind of questions. Run experiments. And I would rather remove MVP from your vocabulary in general. And maybe back to your question, the moment we start probably, it kind of, in the traditional definition of MVP, it is, what's the minimum we try to achieve in the next time frame, iteration sprint? And then it's kind of a minimum viable product, But what worries me is this notion of building a product. And the goal of an MVP is not building a product. It's validating a hypothesis. And maybe just to answer something to Endo, instead of a huge product, yes, we want to find our little product where we build a lot of value and then build the next version, the next feature. And also sometimes remove features. Removing features from our product is a great, great thing. And also very helpful. So I think the short answer would be again, yes.
Just one point to add at the end, that removing feature also means removing code. And code is a liability, not an asset, right? So we have to make sure that we remove those if not needed anymore. But yeah, excellent answer. Thank you.
Reducing tech debt. Nice.
I think, Oliver, we can go to the next.
So our own tech excellence. So, or is that even a question? Slicing is such a smart way to manage work. Would be interested to hear more from Peter about how to structure a team when we work with slices.
This is kind of related to the question I asked here. What if people that slice the product and the people that build the product are not the same? Now, let's go in that direction because I think it's also related to structuring teams. And so you can think about it having one team, but with different skills in the team. But you can also think about it, you have multiple teams that need to collaborate in order to build a product. Now, collaboration in general is a good thing. We need to talk to each other. That's not necessarily a problem. But some people are hesitant to talk to each other, which I found very interesting a lot of times, especially with software engineers. Even if we are just a couple of desks sitting next to each other, people are quite hesitant. They rather use Google or Stack Overflow before they start talking to each other, which is a different problem, I think. Which reminds me to say something. Now, when we have this kind of setup where we have an architecture that is constrained by your communication and by your team setup, you have this two-way connection, which is basically Conway's law. So your architecture is constrained by communication, and your communication is, again, a picture of your architecture that you have. So there's this famous example with the 3-step compiler. You will have 3 teams working on this and things like that. Now, in my experience, also how work comes to the team, the breaking down of the work, the slicing it down has a huge impact on how we communicate and who communicates with who in a multi-team setup. And then again, has another huge impact on the architecture itself. And what I found very, very powerful and helpful in this case is people that are taking decisions in these 3 areas, those people should be in the same room. What do I mean by that? Typically, work is sliced, broken down, created, let's say, by product managers or product owners. Communication, team setup, who is in which team, things like that, is typically created by line management. Architecture is typically driven by a council, an architecture guild, a community of practice, a technical architecture follower, something. Now, if you bring these 3 groups of people together and collaborate, you will have a huge benefit because suddenly some problems will make sense why they will show up earlier or later. And yeah. So when we talk about dependencies, a dependency for me is nothing else than a reminder we need to talk to each other. That's a good thing. And not dependencies are evil. You should minimize. Yeah, of course you should minimize dependencies, but how? It's just a reminder to talk to each other. Then, okay, let's have a conversation every day on a continuous basis. Regarding structuring teams, it depends from a lot of variables, which product you're building. Team topologies has a great material on how to structure teams. Yeah, there is one really, really nice hack that I recommend everyone when you talk about structuring teams. For those who went to a Scrum training, know this one already. Ask the team. Ask the people, how can you work the best to deliver this product vision and collaborate? And people usually have a great answer for that. And that would be my recommendation in general. Instead of having line managers to structure the teams. We know best. No, let them decide.
Nice.
Yeah, what I wanted to add is such a great way to look at the dependencies as an opportunity and a positive way, right? From the positive lens. So it's not evil, it's an opportunity that we can learn from each other and we can drive the scope of the project and we collaborate, namely. So I like this mindset, the positive mindset also applied in software engineering.
Cool, thank you.
So the next question I have is from Tiago. So what strategies would you use to change the way PMs look at this topic? Usually they're biased towards, I've always done this way and worked.
Thank you, Thiago. This is a great question, especially because I've always done it this way and it worked. That's a tough nut, let's say. I'm the same. Like I have a certain diet that I follow, and it works for me. And now you come along, Thiago, and you tell me, "Oh, now you need to eat nuts all every 2 hours, and then you will be whatever." And I think I've always done it this way, and it worked. So why do you want me to change? So what I would do in this situation, if you are in this situation, I would try to find out what is the real problem here. Typically, project managers, which I think is what you mean by PMs, project managers, they have a certain goal. If you mean project managers, I don't know really, but let's assume you mean project managers. And the goal of these, typically of these people, let's not put all of them in one box, but I like to put people in a box, especially if you steer it a little bit and you shake it a little bit, then it's interesting to see the behavior of the people. But let's not do that tonight. Let's assume that we talk about project managers. And in this case, what they typically focus on is scope, time, and money. So they are successful if we deliver within scope, deliver within time, and we don't burn over the budget. If you have such a person in your context, you need to work with them. Second, I would rather try to change the system that you don't need to have project managers anymore, and that you can really have product managers and product owners. Product owners focus on value and risk. And typically that means feedback, that means collaboration, things like that. And what I'm trying to explain or tell you is basically you need to change the system, not the people. And the system is probably in place that you have project managers that are incentivized, assumption, by these things. Now, if you want to change their behavior, don't change the people, change the system around them. Change the incentives, change the how we think about projects, change the way on how the organization thinks about projects. Try to focus on products and things like that. That would be maybe a couple of interesting strategies on what I would use. Yeah. But there is the question has a couple of question marks in my eyes, but I hope I got what you meant with PM and project managers.
But that would be even harder, right? I mean, changing one person, I might. Changing the company.
Yeah. Very hard. Especially if you are the coder in team 11 and now suddenly you go to the boss, and you say, we need to go from project to product thinking. We need to change our budgeting. We need to change our bonus system. We need to change our incentives. That's a huge thing. Mm-hmm. But still, with networking, showing the pain, maybe adding dollars to everything that you discover, you might be successful there. But you're totally right. It's much harder. I hope I covered some bits of your question, Thiago. If not, please shoot me an email.
Cool. So we're actually quite at the end, I would say. So we answered all the questions, and what I have to say now is thanks a lot, Peter. It was very interesting. I mean, I learned so much now in this 1.5 hours. It's amazing. Always like to listen to you. Very nice.
It's a feature from Miro.
Nice. So the last thing I will do is I will now remove your slide and show ours again. So last sentence. If you want to learn how to deliver quality software faster, just join us, become part of our Tech Excellence, and you will see much more of these cool sessions. So see ya.
Thank you, everyone.
Bye.
Thank
everyone.
you.
Thank you,
Thank
Peter.
you. Bye-bye. Thank you,
Bye-bye.
Daniel. Thank you, Nadina.
Thank you.
Thank you.